Let's get started. Today we are going to introduce how to manage the computing environment, especially the Python environments on our shared high performance computing cluster Hyak, and how to connect your computing environment to Conda in Jupyter through a web portal called Open OnDemand. My name is Kaichen Xie, and I'm the HPC staff scientist working with the UWIT research computing team, and we mainly support our users for their research to use the on-campus HPC clusters. So here is the outline of today's tutorial. Firstly, I will just briefly go over our the UWIT research computing, the services we provided, and the user support network we built, and the student access to the HPC cluster through the STF account. And I'm sharing my screen, so can you see? Can everyone see my screen?
I can see it, yeah. I'm on Zoom.
Yeah. Okay. Then we'll dig into the main topics today, how to manage the computing environment on Hyak. And then there will be a hands-on tutorial for you to finish in the next hour. Okay, so for the research computing services provided by UWIT and eScience Institute, the research computing spans many services for the UW community. The job of our team is to make these resources available to you, maintain the resources, and provide user support so that you can mainly focus on your research. After this presentation, the PDF version of this slide deck will be shared and with links to the research computing services and all other resources. We support the high performance computing via our supercomputer Hyak, and part of it is shown here. And we have two clusters on campus right now, Hyak Klone and Tillicum. Hyak Klone is the UW's supercomputer system, and Tillicum is the purely GPU cluster launched last October. And Hyak also includes storage for computing, but it's intended for active computing rather than long-term storage. So we also provide support data storage services via the COPA object storage and the low-load tape storage archive. And UWIT is also a reseller of commercial cloud computing platforms, and we actually offer discounted rates through UW, and we also support staff. As additional data security regulations are passed on, so we have recommended options for secure computing to meet new requirements. And if you have ideas and you don't know exactly what to do about HPC system and your research portfolio needs computing service, we have our research computing consulting team, and we provide domain-specific support in many areas and additional support across campus through our connections to the Office of Research and the eScience Institute. So we will introduce more about the on-campus clusters we have right now. The Hyak Klone for UW's supercomputer. Hyak means fast in Qingnu jargon, and Klone is 3, since this is the 3rd generation of the Hyak cluster deployed. Hyak Klone is a Snorm-based HPC cluster running Rocky Linux, and Snorm is our job scheduler. Basically, using Hyak Klone or HPC systems we provide will give you back your personal or lab computer, and our job scheduler will allow you to run your job unsupervised. And Hyak is unlike Tillicum, Hyak is a Conda model. It means that research groups pay to add resource or condos to the building or cluster that we maintain and support for your research computing. So this provides on-demand access to the resources your group has contributed. But you will be limited by the amount of resources your lab has contributed to that partition. If your group has contributed to 40 CPUs to the compute partition, your group will be able to allocate up to 40 CPUs at any given time. With Conda model, an advantage to go beyond this limitation is the checkpoint partition we implemented. When you request the resources from the checkpoint partition, you can request resources from the entire cluster as idle resources, including GPUs, even your lab has not contributed to it. So this checkpoint queue is managed by a preemptive policy that if a resource contributor requests their resource, checkpoint jobs can be stopped and requeued at any time. And Hyak includes storage for computing, as we mentioned before, but it's not intended for long-term storage. And right now we have more than 40,000 compute cores and nearly 1,000 GPU cores. Tillicum is UW's next generation GPU accelerated computing platform. It is designed to support cutting edge research in teaching and learning in AI, machine learning, data science, and scientific simulation. Tillicum is a word in Chinook jargon meaning the people. It was launched last October, and it is designed around the cutting edge NVIDIA H200 GPUs with ultra fast interconnect and high infinite band network. So Tillicum enables researchers to move beyond the limits of traditional high-performance computing cluster with transformative performance and efficiency. Unlike Clone, working with a Conda model, Tillicum is charged at usage base. So users will pay as they go based on the GPU hours they consumed. And we build a rich user support network to help our users to maximum their time by conducting research. And here's how we can help. We have a help desk that you have any questions, you can send emails to help@uw.edu regarding our services or any research computing consulting. And we also hold office hours from our team and as well as the data scientists at the eScience, both remote every Wednesday and in person every Thursday. So you can learn a lot from going to eScience and then we also offer regular training opportunities like this one, the trainings and workshops. And they are all recorded. You can stay tuned to check our event calendar. And we also have a mailing list to send the announcements and notifications. So for online resources, we have a documentation website that provides step-by-step guides to tools and softwares, and also the monthly blog posts with updates and links to all the support and services mentioned in previous session. And if you are new to high-performance computing cluster, a great resource for learning is, or great starting point is the learning resource we have on our documentation website. We have short how-to videos and also the full-length tutorials. As I just mentioned, that Hyak holds student resources provided by the Research Computing Club. The RCC has been successful at applying for annual block funding from the student technology fee. Each year, they have added resources to Hyak and have a total of 24 nodes for HPC and GPU computing on 24 GPUs. As a student, you have free access to Hyak through STF account, and STF users can schedule jobs with priority to run on Hyak resources. And students are using this for thesis, dissertation, or their own exploration and development of technical skills. And we are in the progress to launch the STF account for Tillicum, so just stay tuned. The RCC also has a cloud credits program when students are inviting to apply for a $500 of computing credits from AWS. And RCC also has an active Slack community where we regularly post updates about training and job opportunities relevant for folks interested in developing further in computing. And each year with UWIT and eScience, we host a hackathon where we can learn together. Okay, so now let's get started with the topics we are going to introduce today. How to manage the computing environment on Hyak. The main components are focused on Hyak Klone, but they can all be adapted to Tillicum with just minor modifications. And so the main approaches to get softwares on a shared environment, such as Hyak Klone, are listed here. For both Hyak Klone and Tillicum clusters, you can load pre-installed softwares through modules. You can build software stacks inside the containers, which provide you with isolated environment. And you can compile packages from source code. You can also use package management software such as Conda, Spec. Here we showed you the login screenshot for the clone and Tillicum. A successful login will display
So someone in the Zoom had their hand up. Did you have a quick question? You can unmute yourself. Sorry, they put their hand down. Maybe they don't.
Yeah. Never mind. Okay, this good. Let's continue. Okay. So once you see this, your home directory will be created. So that needs to be done at least once, and it will also show you the reserved maintenance at the login banner here. So you can use as control show RES to show the all reservations for the maintenance. For both clusters, we have a monthly maintenance reserved at every second Tuesday. Yeah. The second Tuesday of every month. Yeah. So today we will now dig into the how to build containers or compile packages from source, as that's more advanced, and especially it requires a more user-specific guidance. So we will just focus on loading modules, and manage your environments or build your own computing environments with Conda. Okay, so for modules, simply speaking, it just load pre-installed softwares. For Hyak Klone, the one thing to know is that for Hyak Klone, because it's a growing cluster and it's already pretty large, so we disable the module commands on login node. So if you want to load modules, you will need to at least request an interactive compute node. And Hyak use the LMOD environment module system to manage software. Through LMOD manage the modules through module files. it will allow you to switch between different software versions, maintain a software stack, and use compiler and MPI compatible builds. So it avoids manual environment configuration. Instead of manually editing the environment variables to find the binaries or executables, you simply load or unload modules. So for example, here, if you want to load a GCC compiler to compile your own packages, then if you run GCC -- version, you will see a system GCC that comes with the Linux system. So that's pretty old. And then I first request an interactive node, and you will see that a job followed by the job ID and tell you that your job is allocated. And after you are allocated an interactive job, the prompt will change from the login node to the node list of the compute node. And yeah, and then you can run module avail. It will list all modules visible in your current environment after starting an interactive session. So please be aware that module avail only works well with a flat module system. So if you have a hierarchy structure, then it won't show you all the available modules, all the installed modules. It will only show you the modules that can be loaded directly. And you can see that there are a lot of modules on Clone. And if you are interested in a specific package, you can search with module spider, followed by the name of the package. Here is GCC. Then it will show you all GCC installation with different versions on the cluster. So if you load a GCC, without the slash version, it will load the default version for GCC. And then here, if we run GCC -- version again, you will see that the GCC executable changes. And you can also load a different version of GCC, and it will swap the module with a different version. So here, I just list some core commands for lmod commands. And the module command will set the appropriate environment variable independent of your shell. And if you are interested, you can learn more, use the manual for module, or refer to the Klone and Tillicum documentation page. Yeah.
Is it normal if you not get this as allocation thing to work?
If it hands if it just hands at this state, then it means that your job is staying in the queue, is waiting in the queue.
Okay.
Because as a shared environment, we have a lot of users, so all of the users can submit jobs at the same time. So there will be a queue that your job may subject to, yeah.
When I just write down that line of code, it just did not give it.
Oh, you have to put something behind N.
Space, you mean?
Yeah.
Okay, so any questions from online attendees? Okay, so for searching the modules, basically module avail is not for searching, as we mentioned. This especially applies for Tillicum, because unlike Hyak Klone, Tillicum has a hierarchical module system which does not display all the modules with module avail. This is because Tillicum is a GPU cluster, and we want to avoid the conflicts of CUDA MPI and your package. Yeah. We want to have more consistent dependencies. And on the contrary, module spider command will perform a deep search, and it will down to all the hierarchies trees and even the ones that are not currently visible. So module spider is the most reliable way to search install software and learn what prerequisites must be loaded first. So for example, if you run module spider followed by the name of the module, then it will report all the versions of the modules that match the name. And if you provide the full name, which includes the name / the version of the module, then it will report the detailed information, such as the dependencies on a particular module version. And so please remember, always use module spider instead of module avail to find out how to load a module. So basically, loading modules what it really does is it modifies your share environment variables through module files. And there are several commands to reveal the contents of module files. Here we use the module show command. It displays the commands executed when loading the module with module load. And it's shown here are the commands that run in your user shell when loading a module called Jupyter/minima. There are mainly two types of changes applied. The change to the path variable and the setting and the set environment to setting the environment variables. So those will change the path that the system search for the batteries or executables, and also change the library path that the system will search. So please refer to the training materials Git repo and also our documentation for more information about the module hierarchy structure on Tillicum, and we won't dig into that here. With this in mind, then how can we manage our Python environments on Hyak? So we recommend to do that through the Conda environment. So basically, Python is a widely used general purpose programming language with a very rich ecosystem for scientific and machine learning libraries. And on Hyak, Python is mostly used for frameworks such as PyTorch, TensorFlow, and also widely used for general scientific computing or data analysis. Since Hyak is a shared HPC platform, and the users do not have root or administrative access, you will need to install and manage packages in your own environment. So we recommend do that in the user control environment through Conda environment or containers if you have complex dependencies. Hyak Python environments for Conda, it's recommended for most workflows, but the containers we have is the Aptainer, and that's for complex or GPU-dependent software stacks. Conda allows you to create isolated environments that include specific versions of Python libraries, tools, or other packages. This is essential in an HPC environment where the reproducibility and dependency control are critical. And Hyak provides a minimum Miniforge Conda installation that you can utilize to build custom Conda environment. You must load it before using Conda. For clone users, please make sure that you run the module load command on a compute node. So after loading the system Conda module with module load Conda, you do not need to run Conda initialization or modify your shell's startup file. The module, the Conda module itself handles all the environment setup for you. And if you, without loading without any Conda environment, if you run the which pattern to locate the path, the full path to the pattern executable, actually you will see something like this, and also a very old version. This is the system pattern installation comes with Hyak, but it is actually not intended for user computational workloads. Hyak also provides the shared mini forge module with pattern can be loaded and then activate the base environment. And the recommended workflow is to create and manage your own custom Conda environments so that you can control the pattern version and install packages. If you activate the base environment and run the which pattern and pattern version again, you will see that the pattern executables are now in the system Conda environment, and also a much newer pattern, which should be compatible for the modern workflows. And besides, in addition to the system default one, which only comes with a very minimal installation, you can create and manage your own Conda environment. And here, it's very important to choose where to store your environments and packages. By default, the system Conda will store environments in your home directory. And that's what we want to avoid, because your home directory on Hyak, no matter Hyak Klone or Tillicum, it has only a 10 gigabytes storage quota, which is often insufficient, and we receive a lot of tickets and ask for support, telling us that they see this quota exceeded. So in a lot of cases, that's caused by they install everything in their home directory. And yeah.
You're suggesting that we have our own environment or
Yeah.
use the base?
I'm suggesting using your own, create and manage your own environment.
Okay.
Yeah, because the base environment, it only has pattern. Basically, it has nothing. Yeah. In your home directory. And okay, I should say more about the storage system, the file system on Hyak. So there are three storage spaces, basically three types of storage spaces you can utilize. Your home directory, which we recommend you only save configuration files and scripts. And the other one is your project or lab dedicated storage space. And STF also has its own dedicated storage space like other groups. And the third one is called the scrapped storage. That's the scratch storage that intended for active computing. So any contents you save there will be purged in 21 days, if I remember it correctly. If it's not touched or if it's not being accessed within that time period. So there is an auto deletion policy for the scrap storage, but you will have potential much larger storage space there to run large scale computing, or if you have a large data sets, then you can utilize those storage from scrapped space.
When I wanted to just create my own environment, it's like Conda, no plugins, install errors kind of thing. So I cannot do it.
Okay, so I will just continue with this one. And so there are two options for you to customize the locations to store your environment. The first one is use the prefix flag argument or flag for explicit paths that can be applied for every single environment. So you can save every single environment in different locations. But the disadvantage is that you need to provide the full path to create and activate your environment, and that's very long. So basically the recommended way is to configure defaults in the Conda configuration file in your home directory. That's the file saved in your home directory /.conda.rc. And if it's the first time you load Conda, then you don't have this file in your home directory. Then in that case, you need to create it. You can use nano to just open that file and it will be created. And you need to so add those lines to the file opened, but replace the my project, my folder with real paths and save and exit. So here the my project, my folder is intended for, because we recommend you to store your environments in either your project dedicated storage space or the STF account storage space. For the scrap storage, there is a risk that your environment will be broken because for some of the packages, the time is not counted when you install or download it. And I think the access time will be the time that package added to the Conda channel repository. So all the time of the source code. So there is a chance that your environment will be broken.
How frequent?
Gscratch is the name for the whole file system, but the community resource I mentioned is scrapped. Yeah, it will be cleared 21 days, if not touched. So if you no, for Gscratch, if you have a project or lab dedicated storage space, then it won't be cleared. As long as for Tillicum, as long as your lab still have access to Tillicum. For Clone, as long as your groups still hold hardwares in Clone. Yeah.
That's not fast access.
Gscratch, yes. So it's intended for active computing. If you have finished projects, then we recommend you to transfer your data to a more long-term storage space, such as the Lolo tape archive or the Copa storage. Yeah. Or even you can explore the option to build to have a SharePoint. I think UW provide the SharePoint for UW students groups, and there will be 25 TB storage. Yeah, so you can explore that option. And so basically you don't need to finish all those steps right now. They are all included in the hands-on session. But you are welcome to follow the steps. Yeah. And then after you create and edit this configuration file, make sure to save the file and then exit with, I think it's Control X and Control O. And then load the Conda module and create your own environment. Say here we create an environment named my environment, and then we install packages including Python with a specific version, NumPy, SciPy, Pandas, Matplotlib. Without this version, it will install the recommended or the default versions. Yeah, but you can always define a specific version for the packages you want to install. And then after you finish the installation, activate the environment. So for Hyak Klone, yeah.
Taeyun, do you wanna unmute yourself in the chat or in the Zoom?
Sorry, it was mistake. Sorry.
Can you say that again?
Oh, I wasn't in. It was. I wasn't trying to raise my hand. Sorry, I misclicked it.
Oh, it was an accident.
Oh, okay. Yeah. Yeah.
So I'm seeing like the comment files, there's a basic. And there's the file. The file directory says it's MMFS what is that?
Oh, that's the I think that's a remaining issue when we deploy the system. So that's just a path that added at the beginning. And we have created symbolic link to the full path. So you don't need to include that.
Oh, so when we install our own various G-Scratch, right?
G-Scratch basically is a directory under the MMFS1.
When we install our own file, it's directory.
It should be G-Scratch. And for this tutorial, we will use G-Scratch/script your UWIT ID Conda environment. So this is the recommended setup if you want to work on your own project later. But for today's tutorial, we will create environment in the script folder. Yeah. And that's included in the hands-on session. So basically you just need to follow all the steps in the hands-on session. So here is the recommended setup for you to work with your own project or your own research. And what I'm at no. Okay, so yeah, so for Hyak Klone, the Conda create environment may take some time, or the installation, if you want to install any packages, it may hangs at one step. So if that happens, just wait for some time. And if it hangs for 10 or 20 minutes, then you can press Ctrl+C to terminate the process and rerun the command. Because the file system is quite busy right now on clone, so sometimes it will just stuck at one step. And then with Conda environment activated, you can install your own packages with Conda install. The one thing to note is that for packages installed with Conda install, it may install packages from different channels. The Conda have different channels for packages. In many cases, it's fine. So you don't need to provide which channel you want your package from. But sometimes it will need to version conflicts, or if you want a GPU version, it installs CPU version for you. So sometimes you will need to provide the channel, which channel you want to install from. So that can be specified by -C. And yeah.
So if we have a container to install all of these,
Mm-hmm.
do we need to first do the installation and then have the container install everything again? Or
if you want to have a container for all of this, then you will need to have your own the Conda installation itself inside that container. So you will need to initialize Conda at first, and then you can have a definition file for your container. So in the definition file, you should have the Conda installation command and then the initialization, and then run all those installation commands. Yeah. And then to check the packages installed in current environment, you can use Conda list. Another way to install packages is to use pip install. The best practice to run pip install is to use it inside a Conda environment to install packages into the current environment. Otherwise, pip install will install package into a local cache, and usually that's somewhere this folder under your home directory. So that's also what we want to avoid. So we recommend always using pip install inside a Conda environment. Or you can use a container. And to do that, you can module load Conda and activate your environment and then run pip install. So for example, here you can install Torch or Torch Vision. And GPUs are a good fit if your applications can perform computation using large arrays, matrices, or you want processing images. Your data set can fit in the GPU memory, and the input-output is not a bottleneck for your computation. Then you can also use GPUs with Python. And here, you will need to load Conda module at first before you install any packages. Also for CUDA-aware packages, all of them should be built on a GPU node if you install them with Conda or pip. And some GPU-enabled packages are installed from the Conda Forge, which is the default channel will be used by this system Conda. It will install CUDA toolkit into your Conda environment. This may conflict with the CUDA toolkit module that is noted. So please be aware of the version controls if you have complex dependencies. And so for example, here we show how to install CuPy, which is a CUDA-aware pattern from Conda Forge channel. It will pull CUDA toolkit dependencies into your Conda environment. So in that case, you will at first request a GPU core. So the way is to add the GPUs per node flag with the type of GPUs and colon and the number of GPUs. You can check the GPUs you have access to by the command Hyak alloc. Please check that from our documentation website.
So we do not need to install CUDA?
No. CUDA usually CUDA is already provided as a module. Yeah.
So we install CUDA environments in our own like G-Scratch directory.
Mm-hmm.
And then when I type in like Conda environment list, there is no like environment pocket hub. Instead, I have to activate it and send them. There's not like the environment that it's not.
Because you load so you have your own Conda installation previously?
Yeah.
Okay, so then have you created any environment?
I can't create an environment like under an over directory that says I don't have permission.
Yeah, so in that case, it will force back to your home directory.
It doesn't specify it.
I think that's because have you defined the Conda RC file? Have you?
Well, oh yeah, right.
Mm-hmm. Yeah. So okay, so we activate the environment and install the CuPy package from Conda Forge. So if you want to install packages from a specific channel, just add this flag -c and followed by the name of the channel. And then if we launch Python, and we can import the CuPy as a module. So just be aware that login nodes, no matter for both Hyak Klone and Tillicum, login nodes are CPU only. So if you want to install anything with CUDA aware, please request that GPU node. But I think for container, you don't need to do so. Yeah. And just refer to the training materials to learn how to run Python script interactively or with a batch job on the cluster. Here we won't cover that content, but that's covered in the training materials of the Python section. Yeah.
Could you please go through that again, about, GPU and CPU?
I'm sorry.
About GPU and CPU, you said make sure to use GPU.
The today's tutorial won't cover the GPU contents, so I just mentioned that in case you will work with GPUs. Yeah. Okay, so then you can use Python with Python script directly with command line interface, either run it interactively or with Snarm bash job, running it unattended. But here we will focus on how to run Python using Jupyter through Open OnDemand. Both Hyak Klone and Tillicum provide access to JupyterLab and Jupyter Notebook through a web portal called Open OnDemand. And here are the links. And Open OnDemand is a web-based portal that provides an integrated single access point for remote HPC cluster. It allows you to perform many common tasks without command line interface. That includes managing files, upload, download, or edit, and monitoring running jobs and resource usage besides the SQ command. And you can also launch interactive jobs such as Jupyter, RStudio, VS Code. And it also provides a virtual desktop. So here, yeah, a virtual desktop to display a remote desktop for software graphical user interface. So you can use it for MATLAB, console, yeah. And Open OnDemand Jupyter interface allows you to run interactive Jupyter sessions in the home directory on compute nodes, and this makes it especially convenient for workflows such as interactive data analysis and notebook-based development. So first, log into Hyak Klone Open OnDemand using your UWIT ID and the dual authentication. If you, for remote attendees, if you access Open OnDemand from off campus, you will need to connect to the UWVPN at first, and you can find the instructions in the tutorial. So when we come to the hands-on session, you will find the instructions. And then from the Open OnDemand dashboard top menu, select interactive apps on Jupyter to navigate to the Jupyter app. You will be prompted to configure the resources for your Jupyter session. So in that case, you will need to configure the form with the account. So set it to UWIT if available. And the partition, you can check. It will show you all the partitions you have access to, and you can choose checkpoint queue. That's the community checkpoint resources, but the queue time may vary. And also for the server environment, the environments listed in the form are maintained by the Hyak team. But in addition, you can also create your own Jupyter Apptainer image. And in that case, just select custom container. And then the Jupyter user interface, we recommend using the JupyterLab, but you can also use the classical Jupyter Notebook interface if you prefer. And then below this, there will be fields that set up the resources requested for your job, including the number of cores, the time, memory requested, and also an optional GPU settings if your workflow requires GPUs. And in the end, there will be a launch button. After submission, the Open OnDemand will submit the interactive session as a Snarm interactive job under your account. and it will wait for resources to become available. Then when the resources are ready, your job is allocated to a compute node. It will show a connect to Jupyter button here. And so let's take a look at this session, the interactive session cards. So you will see the Jupyter followed by the Snorm job ID. So that's the scheduler identifier. And then the host where your job launched. This is the compute node running your job. And then the status here. Yeah. And it shows it will change to running when the job is ready. And here is a session ID. This is the link that you can click it. It will navigate you to the detailed logs for troubleshooting. And click the connect to Jupyter once the job is running. And a new browser tab will open with your lab Jupyter environment running on a compute node. So this is the browser tab. In the launcher tab of your JupyterLab session, you will see all available kernels under the notebook session. By default, you may only see this one, because this is the system minimum pre-installed system minimum installation. So you may only see this one. Most of the others are my own environment. If you click on this button, it will start a new notebook with the Jupyter kernel. By default, yeah, it will just start the new Jupyter notebook with the system minimum Python kernel. So I want to talk a little bit more about the Jupyter kernels. The full name is the IPython kernel. It's what it used. IPyKernel is a separate process which is responsible for running your code. The front end, such as the notebook, it will communicate with the IPyKernel using JSON messages sent over sockets. And the core execution mechanism for the kernel is shared. The core execution machinery for the kernel is shared with the terminal IPython. A kernel process can be connected to more than one front end simultaneously. And when you save a Jupyter notebook, this is sent from your browser to the Jupyter server. And it will save it on disk as a JSON file with .ipynb extension. The Jupyter server is just a communication hub. The browser notebook file on disk and kernel cannot talk to each other directly. So they communicate through the Jupyter server. And the Jupyter server itself is only responsible for saving and loading notebooks. So you can edit, you can even edit notebooks even if you don't connect to any kernel for that language. You just won't be able to run code. So the kernel is the real thing that run your codes. The kernel itself doesn't know anything about your notebook document. It just gets sent cells of code to execute them when the user runs the cell. And you can choose from server environments for Jupyter on Open OnDemand. So just as we mentioned, here are the server environment options we provide. And the system default one is the modular Jupyter minimum. And there are also a few server environments launched from the container with more packages installed, and also an option for the custom container you prepare yourself by yourself. And besides the pre-installed minimal environment, you can also use your own Conda environments as Jupyter kernels. Just make sure that your environment has the ipython package installed. So here is the ways to register your environment as a Jupyter kernel. So first, activate your environment and then run make sure to have ipython installed and then run ipython install command in your activated environment to set up a Jupyter kernel specification file. The kernel spec file will be created and saved in your home directory under this path. And if you switch back to your Jupyter interactive session, the kernel with this display name, Python my environment will be present in the kernel list. Any packages installed in this environment will also be available to you. Here I just show an example kernel spec file, the kernel.json file, for the environment, for a customer environment. And the key fields here are the arguments, the argv. It's the command line arguments to start the kernel. And the display name is the name that will be shown in the Jupyter interface. And the programming language here is Python and can be Python for ipykernel and R or Julia. So you can choose your own language, but you need to install the corresponding kernel. And optionally, you can also have environment variables to set for the kernel or any additional attributes about this kernel. And just want to make you aware that the container can also be registered as Jupyter kernels. This allows you to run notebooks inside a containerized environment with Jupyter. To register a container as a Jupyter kernel, I think the simplest way is to start with a basic kernel spec, such as this one, and prepend the command argv with the container runtime command, such as the obtainer command and the options. And then create a kernel.json file similar to this example below. Similar to this example and put it at the directory, the same directory in your home directory, but with the name you want to name your container environment. So if you want to work with this example, then you will need to change the path and also the name to your container image and also the path to the Python executable inside the container. And also the display name that you want to call it. In that case, we would recommend you to use proxy jump approach instead of Open OnDemand. Open OnDemand are all predefined, especially for VS Code. It's launched from a predefined code server container. You can find that on our website. We have a tutorial for that. We have both documentation page and a full tutorial for that. So if you run into any issues with Open OnDemand or Jupyter on Open OnDemand, you can reach out to the help at uw.edu with we mentioned the snarm job ID and also the session ID. At first, you can troubleshoot yourself with by clicking into this link, and it will show you a logs of your session, and then you may find there are some error messages. But if you still have questions or problems, then you can reach out to us with the snarm job ID and session ID. Then we can take a closer look. Mhm.
Is there any limitations for the running time? Or the CPU and GPU?
For checkpoint queue, we don't limit the total runtime, but for CPU, I think it's every 4 to 5 hours. Your job will be requeued, and for GPU, it's every 8 to 9 hours. Your job will be requeued, but that only applies for the checkpoint queue. If you are using the dedicated resource contributed by your group or STF account, then you have on-demand priority access. So your job you can request as long as you want, but it will also be limited by the monthly maintenance. Yeah, so for the monthly maintenance, every Tuesday, every second Tuesday of the month, the whole cluster will be done. And if your runtime exceeds that date, your job will be held until past that date. Yeah. So we will send notifications for the maintenance date if you're joining our mailing list.
Yeah.
Mhm. Okay, so basically that's all for the presentation part. And by completing the tutorial, you will learn how to manage computing environment with modules and Conda environment, and also create your own Conda environment and install packages, and then launch Jupyter server on Hyak Klone using the Open OnDemand web portal, and register a Conda environment as Jupyter kernel. And we have training materials repo. You can find that in the email we sent you or in the chat channel for online attendees. And also after you finish the tutorial or after this workshop, please, we are glad if you can fill you can fill the feedback survey to let us know what you feel good or what you think we can improve. And there's just one thing you need to know for the training access period. We have added you to the UWIT account so that you can have access to that account for you to get your job ready faster. But you will be able to complete whenever you want with your demonstration account or the UWIT account over the next 3 days. So that your access to UWIT will end on the Monday morning. That's March 9th. And this tutorial is designed as introductory concepts, and I will just follow up later. There will be a practice followed by a task that combines those skills introduced. And here are all the useful links for the services and support we have. You can check this later. I will put the PDF version for these slides in the tutorial. So,
Jen?
mhm.
So we have office hours right now at the
Yeah.
same time, so I'm gonna go out to office hours and maybe you want to join me to fix your trouble. But if anyone else needs extra support, I'll just be out there.
Yeah, I will be here to answer any questions you have.
Maya will be watching that.
Yeah, just a quick walkthrough over the hands-on exercise. So,
Thank you.
okay, so here is if you navigate to our tutorial, here is an overview of the training materials, and all the contents I presented today are covered in those materials, and there are more extensive readings in those modules. And then for the remaining hour, please follow the steps in the hands-on exercise to run Python in Jupyter on Hyak Klone. And here you will create a working directory and start an interactive job, build a custom Conda environment and register that environment as a Jupyter kernel, and then launch Jupyter through Open OnDemand and run Python inside the Jupyter notebook with your custom environment. And before you start the first step, just check out the preparation part. So in here, yeah. So it will show you all the preparation, especially for the storage part, that to create your own folder in the scrapped folder. Yeah. So that's all for the first half of this of this workshop, and then I will just leave the remaining time to you to complete the hands-on tasks. And I will be here to answer any questions or provide any